What's up, guys? It's Evan from Flag Motorsports. I've got our H85A Rottler hone fired up. I got an LTR block in there getting honed, and I figured it would be a great opportunity to take you guys along as I go through the features and kind of the process of how we hone these blocks. We've got some really cool tools. We've got an amazing piece of machinery, and I really wish this video existed when I was going to buy this machine because I had so many questions. How does it work? Why is it better? Et cetera, et cetera. But it turns out if you're spending the ridiculous amount of money it takes to own one of these, you're probably not focused on YouTube videos. You're probably focused on trying to make your investment back. But anyway, regardless, I found it tremendously interesting going through this machine and seeing what it can do, and I figured I'd share that with you guys at home, and that way you could check us out and see if we're building you a whole long block, a short block, if we're just doing machine work for you, what the process looks like. Because even though this is an LTR and all fancy, every single block that gets in this hone gets pretty much the same process. So we're going to bring you along, and yeah, come on in, I'll show you about the machine. First off, I'm going to talk about the block we have up in the hone. It's a brand new LTR block, and we've got a big old hunk of aluminum with some studs sticking out on top of it. That's going to be a torque plate. What that does is it simulates having a cylinder head bolted to the block. If we didn't have those torque plates, I could make the bores perfectly straight and round, but as soon as we go to assemble the engine and put a cylinder head on it, all of the hard work that we did to get everything straight would become out of round again. So we put those plates on there to simulate the cylinder head, and that gets us a perfectly round bore that mimics what it'll be in service as close as possible. Next thing I want to highlight with this machine is that it is a diamond hone. And what that means is the stones that we're using to cut are made of diamond. It's a diamond abrasive. And the finishing step is using a CBN abrasive. This differs from a lot of the old school hones in that they use what's called a vitrified abrasive, and it's almost like a knife sharpening block, and it's kind of a gritty stone that wears away as you're using it. The diamonds are much, much harder, and they do a much better job at maintaining bore geometry. So the vitrified stones, typically there's going to be 2 stones per head. This has a total of 6. So what that's going to do is the 2 stones would tend to, if this bore was shaped like an oval beforehand, those 2 stones would follow that oval and do a poor job at getting it to be back round again. Because we have 6, they're going to do a much, much better job at forcing the bore geometry to straighten out, and because of that, we're able to get tremendously round and straight bores, and that's one of the big assets that this machine has. The other cool thing about the head is that it goes directly up and down, meaning the head just comes up and down. And the old school machines are going to use a cantilever design where it's more of a sweeping travel. And so that will create other bore geometry issues rather than just going straight up and down. Another neat feature of this machine is because of the diamond stones, we use a coolant coming out of the machine rather than an oil. So old school machines are going to use a cutting oil. And at face value, that doesn't sound like a big change. However, with the vitrified stones and honing oil, oil doesn't really cool down what we're working on. And so this block, after we start honing it, will increase temperature. It'll get hot because of all the friction of everything that we're doing. And so now that we've got coolant, that coolant is actually going to maintain a very stable temperature of the block. What that does for us is, while we were honing the block before with the old school stones and everything, and it was heat cycling, we'd have to stop, let the block cool down, and then take our measurements. And that added a tremendous amount of time to the honing process. The diamonds and the coolant are very accurate, and they get it to size, and then you're able to measure it right there, and it's not going to change temperature or change size at all. So that's tremendously helpful for getting really accurate bores and also being really efficient. The other really cool thing about this machine is it's got a rollover fixture where all I got to do is do that, and then I can go ahead and do each bank at a time. Makes it really fast and easy. So now that we've talked about the stones and the coolant and all the other features of this machine, I'm going to start talking about kind of our measuring tools. This is going to be pretty much industry standard. This is a dial bore gauge, and it's a Sunnin. It's a very nice one. I like that it's retractable so I can go in without scratching up the bores. And this is what we're going to use to get our sizing. So this tells us, it's jumping all over the place because this block is just sleeves that have been pressed in, so that surface finish is very uneven. But that bore gauge is going to give us a very accurate measurement from when we measured our pistons. That's what we're going to set our bore gauge to, so we're able to know exactly what our piston to wall clearance is on these cylinders. So that's the tool that we're going to be using to measure. It's going to tell us how round and straight and to size everything is going on. The other cool tool that we've got is going to be a profilometer. We're going to go over what this does later in the video and how we use it, but its basic purpose is to measure on a microscopic level the surface finish of that hone that we just did. And that's going to give us a really good picture of what that ring sealing surface and oil retention area is, at a microscopic level. Taking a look at our console here, you can see some of the tools that we have at our disposal. We've got basically the manual jog parameters for the CNC aspect of the hone. This is how I'm going to move the spindle and the stones manually. It has a Z crash detection, which is awesome. Basically, that head is going to come down. You'll see it when we actually start honing. Once it sizes them, it's going to start coming down. It's going to go down slow so that it makes sure if there's anything at the bottom, like a main bulkhead or whatever, if I set my settings wrong, it's going to stop and then pull it back out and tell me, hey, you're being an idiot. Don't do that. So that's a fantastic feature. Love that thing. This is our load meter. So you'll see as we're honing, in real time, it shows you what the geometry of the bore is. You can see a red line. It's going to look all crazy when we first start, and then once the cylinder is kind of at size, you'll see it nice and straight. So that's what you're going to see happening here. This is basically going to be our material removal settings and how much we want it to remove. But once you set it for one bore size, it's going to remember that and carry that over for all other 8 bores, and it's going to get them to the same finish size. So it doesn't matter if one hole is different than the next one, then the next one, then the next one. It doesn't care where it starts. It only is tracking where it finishes. So it does a really amazing job at that. And yeah, we're going to get into actually honing it. I went ahead off camera because it's a little hard to focus. I got this bore set up and got our sizing set. These are about 15 thousandths smaller than our final size. And because I haven't used these exact grit stones with these sleeves and this block and this exact configuration, what I'm going to do is I'm going to pretend and make it 10 thousandths smaller than it's going to be, but I'm going to pretend like that's the final bore size, and I'm going to use that opportunity to get 8 trial runs at getting my surface finish exactly where I want. That way I'm going to have a really good idea once I get these to size exactly what my process is going to look like, so I can get exactly the settings that our ring manufacturer called out. So I got that one set. What I'm going to do now is go ahead and lower the hone in, being very careful because it's a little hard to see with the torque plates. So all I did was get it down inside the bore. Then what I'm going to do is hit this feed stones to diameter button. What that's going to do is it's going to bring the stones outwards until they're just starting to touch the bore. Then all I got to do is hit cycle start. It knows it's going to remove 5.5 thousandths material, which makes sense because it's starting at 15 thousandths small, and we're going to 10 thousandths small. So it's just going to start honing away. And this thing is all over the place. You're going to see it dwelling a bunch at the bottom and at the top just to try to get this bore straight, because these things are definitely not straight as they come. And one of the best things about this machine is I'm sitting here talking to you and focusing on making a YouTube video while it's doing all the work of getting our bores perfectly straight and round. And it does such a better job than any of those older machines ever could. Even when you're babysitting them with a skilled operator, you know, their tolerances are only so good. And this machine is able to get much better tolerances with very little input from the operator. And that's really what I was paying for when I got this machine, is just ease of use, and on top of that, the tremendous benefits of having a perfectly straight and round bore can't be overstated. If you talk to any of the ring companies, talk to Total Seal, they've been fantastic advocates of proper bore finish and geometry, and you can see a lot of the results. We'll see anywhere from a 20 to 40 horsepower gain over a tapered bore and out of round bore, just because we're able to get those rings to seal so much better. And we're able to really get fantastic results as far as wear as well, because that crosshatch pattern is going to do a much better job at holding oil on the bore where we need it and giving our skirts a really good film of oil to ride on and prevent wear that way. So this machine, the amount of benefits, off the chart. I mean, we're getting a better end result. We're getting an easier process. Kind of the only downsides of these machines is going to be the cost and complexity to get them purchased and set up. After that, they're much better. The tooling can be a lot more expensive as well. The set of the diamonds is probably around, I want to say 20 to 30 times the cost of a set of vitrified stones. But the nice part about that is you get a really long service life out of them. They're supposed to do about 40,000 bores. So, you know, that's about 5,000 blocks, which should last me a heck of a long time. And we're getting there on size. We've got about 1.5 hours left to go. And so I'm going to shut up and let it finish off this bore, and then we're going to measure it and go on to the next one. Got our bore gauge. Let's go ahead and follow it up and check its work. And it left us about 1/10 to 1/10.5. About the same. Almost 1/10. About 1/10. And we're at a bore and about 1/10. So it's leaving us within 1/10 of straightness all the way up and down. I mean, it's as close to straight as you could ever want. I was happy to hit 3/10 with some of the old equipment we were using. And if I even turn it and check roundness, I'm getting identical measurements. So not only are we getting a straight bore, but we're getting a round bore. And that's what this machine excels at, is bore geometry. Here you can get a closer look at kind of the surface finish before. It's just that smooth, rough bored finish. And now that we've got our rough hone done, you can see the cross hatching coming in and what that looks like. Now that looks a lot rougher than right now than it's going to. That's because we haven't done any of our final finishing steps yet, but you'll get an idea just kind of what we're getting off the rough stones. I've got these 4 cylinders roughed in. Now I went ahead and put our fine finishing stones in so I can go ahead with our Plateau hone. What a Plateau hone is basically, if you can imagine taking that rough grit and looking at this surface finish on a microscopic level, you're going to see like this crazy mountains and valleys. So that's from our rough grit. Now what we're going to do is follow it up with a fine grit, knock all the peaks off, so we end up with plateaus, and basically it's going to come up and be a nice flat area, and then it's going to have a valley and then a flat area. The flat areas are for the ring to seal, and the valley is to retain oil. There's lots and lots of videos and diagrams on that. I'll see if I can attach one in the video so you can kind of see a little better idea of what I'm talking about. But we're going to go ahead with that final grit now, and I'm going to try a different amount of time and pressure on each cylinder to see how that affects our surface finish, and make sure that we get exactly what we want. So now I'm going to clean it and get all the grit out, so when we go and measure it, that grit's not blocking our measurement. There's lots of grit embedded in those valleys I was just talking about. Okay. Now I'm going to take our profilometer. What this is a tiny micro diamond tip that gets drug along the surface like a record needle and measures exactly what that is. It's going to drag across and see what our surface finish is. So there's our peaks and valleys like I was talking about. So that flat area is where the ring's going to ride, and these valleys are what's going to hold oil for us. Perfect. These values are right on the money for what we were looking for. The ring manufacturer told us that they want to see about 40 for our RK. That's the core roughness value. The RPK is the rough peak heights. They wanted this to be between 12 and 15. And they wanted our RVK to be between 60 and 80. So I couldn't have hit the nail more on the head with this one. I guess that's a lucky break. But it turns out it's actually pretty similar to a lot of the sleeves that we use. So what I'm going to do now is go ahead and save those settings. I'm going to check it on the next 2 and make sure that we get similar values. And if we do, I've got my recipe, and I'm going to go ahead and get this block to size and then do this again at our final size. All those checked out perfect with almost zero variance. So now what I'm going to do is go ahead and size it to our final size. Now that I got our settings right, so I'm going to set you up on a time lapse and blow through this. Now that we got our sizing done with the rough stones, let's go ahead and check our work. Nice and straight and on size, exactly where we want it. Really happy with that. Now, like we showed earlier, we're going to go ahead and plateau hone this and get it all finished up. Now that we got it all plateaued, it looks really sharp. It'll look even better once we get it all cleaned out. There's still going to be a lot of grit in those cylinders. But thanks for checking this out. I hope this gave a little flavor of the machine. I'd like to do more videos on this machine. So if you have any questions, ideas, anything you want to see, please leave us a comment. We love reading them. We're having a lot of fun interacting with everybody. And yeah, it was fun to bring you along for an insight into the process in this. This block went pretty smoothly, and I'm extremely happy with the end results. We've got less than 0.2 variance, taper, roundness, straightness across the entire block, and our surface finish dialed in exactly where we need it for this motor. Thanks for checking us out with this hone and following along on this video. If you enjoyed this content, please feel free to like and subscribe. There's going to be a whole lot more coming. We're only just getting started.